Problem 69, we're still trying to figure out whether f is continuous at, in this case, x equals 1. And if we look at the limit as x approaches 1 from the left, the limit from the left is equal to 5 times 1 plus 1, so 6. And the limit from the right, we use this piece down here, and we replace x with 1. 3 minus 2 is 1. So we see the limit from the left is not equal to the limit from the right at 1, so the limit as x approaches 1, does not exist, and so therefore we say no, this function is not continuous at x equals 1. Problem 70, the limit from the left of 0. So we're trying to figure out, at c equals negative 1. So even though the connecting point is 0, it says we're trying to figure out if f is continuous at a point that's not even a connecting point. So we know that f is continuous for all real numbers other than 0 for sure, and so therefore, yes, we would say that yes, f is continuous at x equals negative 1. Okay, let's scoot on down here to problem number 71. The limit as x approaches 5 from the left. So we're approaching 5 from the left-hand side. And are the y values approaching the same number? Yeah, the y values are going right up there to this value here, which is 4. And so we say the limit as x approaches 5 from the left is 4. The question then is number 72. Does the limit as x approaches 4 exist? And if so, what is it? Well, again, let me erase some of this stuff that I already have up here. If x is approaching 4, here's 4 right here, then are the y values approaching the same number? Well, let's cover up what happens at 4. We don't really care what happens when x gets to 4. All we care about is, are the y values approaching the same number? And as you can see, let me get a different color than that. I don't really like that color. As you can see, the y values are following the curve, and they're going right there to this y value, and that y value is 3. And so, yes, the limit does exist. So we can say down here, yes, the limit exists. And if so, what is it? The limit is, what did I say? The limit is 3. All right, and I've been circling everything in red. Hope that didn't throw you off. Scooting on up here to number 78, we're being asked to find the slope of the tangent line to the graph at this point. And again, what we need here is the derivative, because the derivative will give us the slope. 2x plus 11, and then f prime at 1, because f prime depends on x. As f depends on x, so does f prime. F prime at 1 is equal to 2 plus 11, so 2 times 1 is 2, plus 11 is 13. So 13 is the slope of the curve at the point. Slope of the tangent line to the graph at that point, 13. So once we find the slope, we can find the equation of a tangent line. And so let's do that here for number 79. We need to find the derivative first. The derivative of f is, using the power rule, 4x plus 1. And so the derivative at 4, again, the derivative depends on x. So when x is 4, we have 4 times 4 plus 1. So we have 16 plus 1 is 17. Well, we're already given, this is kind of nice, because we're already given the x, and we're given the y, and we're given the m now. We're not given the m, we found the m. And when we find the m, we know we have the x1, y1, and we have the m, so we can just replace all of those values in our point-slope form of a linear equation. And the point-slope form, we subtract y, so y minus our y1 value, which is 33, our m is 17, and our x1 value is 4. So we have our equation of our tangent line at the point that was given, 433. That was a pretty short video, but anyway, I'm not going to try another video on the same screen, so I'll switch pages and we'll get to the next video.